5.1 deals with zero and negative exponents. You should have seen these in a pre-algebra course, and zero negative exponents should have been explained in detail then. So for algebra, we're just going to remind you of what they are and how to use them. Today, we're just going to look at the basics of zero negative exponents. We're not going to do a whole lot with them. So let's look at zero exponents first. For every non-zero number a raised to the 0 power equals 1. Okay, now that may not make a whole lot of sense to you that something raised to a power of 0 equals 1, but basically what you have when you raise something to the 0 power, you have a number divided by itself. And anytime you divide a number by itself, it equals 1. So that's what you have to think of when you see something to the 0 power. It's basically a number divided by itself. So 4 raised to the 0 power is equal to 1. Negative 3 raised to the 0 power is equal to 1. 1/3 raised to the 0 power is equal to 1. Because 1/3 divided by 1/3 is definitely 1. 5.14 raised to the 0 power is 1. So any number that's not 0 raised to the 0 power is equal to 1. So that's zero exponents. Negative exponents can be a little tricky at times. Okay, so for negative exponents, for every non-zero number a and integer n, a to the negative n power is equal to 1 over a to the n. Basically, it's the reciprocal or the multiplicative inverse. So if I see a negative exponent, the way I like to explain it is it needs to move. Okay, so if it's in the numerator, the negative means to move it to the denominator. If the negative exponent's in the denominator, the negative means to move it to the numerator. So a negative exponent, to simplify it, needs to move. Okay, this is the reciprocal. When you see a negative exponent, it is a reciprocal. And that's probably the best way to think of it. Okay, so let's look at the first one. 7 to the negative 3. The negative 3 is telling you to move it. Move it to the denominator. So the reciprocal of 7 of this would be 1 over 7 to the third. Okay, so you move the 7 to the negative 3 to the denominator. You take off the negative, and it's a positive 3 in the denominator. Negative 5 to the negative 2 is equal to 1 over negative 5 squared. 1 over negative 5 squared. Okay, the negative comes off when it's moved to the denominator. The negative means to move it. Now this one is in the denominator. It's 3 to the negative 4 in the denominator. To move it, you move it up to the numerator. And when I do that, the 1 is just multiplied to that, so the 1 really is not needed. It is 3 to the 4th in the numerator. The negative comes off. Basically, you're just flipping this back over. You're taking the reciprocal of 1 over 3 to the 4th. Okay? And then 1.2 to the negative 3. Again, the negative simply means move it to the denominator, or flip it over if you want to think of it that way. A 1 on top, okay, it's the reciprocal. It's a reciprocal of 1.2 to the third, so that equals 1 over 1.2 to the third power. Again, when you put it in the denominator, the negative comes off because it's been moved. Okay, and that is the explanation of zero negative exponents. In the first example of zero negative exponents, we're going to simplify. To simplify simply means to get rid of the negatives and get rid of the zeros. Not the negative numbers, but the negative exponents. Okay, we can have a negative number, but we don't want a negative exponent when we're simplifying. And we certainly don't want a zero exponent when we're simplifying. So to simplify this, the negative, again, means to move it to the bottom, or you may say it means to flip it. So I get 1 over 7 to the third. That's terrible writing. Writing on a tablet is not easy to do for me, but that's it. Okay, this whole thing raised to the 0 power, anything raised to the 0 power simply equals 1 because you're dividing a number by itself. Okay, now this one's a little tricky. This is not the same as this. This has parentheses, this doesn't. Remember, with order of operations, exponents, parentheses and exponents go first. Multiplication second. Multiplication, division second. You have to think of this, I think it helps to think of this as a negative 1 times 3.5 to the 0 power. So the negative is a separate operation than the 0 power is. So you have to take 3.5 to the 0 power, then multiply it by negative 1, which should give me negative 1. Okay, negative 1. Again, you're raising this to the 0 power. Again, sorry for the bad writing. And that equals 1. Then you tag the negative onto it, so it's negative 1. okay? 1 over 5 to the 0 is really equal to 1 over 1, and that equals 1. And that writing was a lot better. Okay, here again we have the parentheses. Okay, so we're basically taking the whole thing and moving it to the bottom. Everything in the parentheses, the negative tells us to move it to the bottom. So we're going to write 1 over negative 7 in parentheses to the to the third power. There's an eraser. Can't get an eraser. Let me go back here. 1 over negative 7 to the third power. Okay, we take the negative off when we move it down. Keep the parentheses there because the negative is being raised to the third power along with the 7. Okay, now notice here there's no parentheses. So the negative 3 is just affecting the 7 and not the negative. Okay, so if we want to do this one, we can leave the negative on top with the 1. And we move the 7 to the negative 3 to the bottom. The negative 3 becomes positive 3. The negative 1 is not really attached to this 7. It's not being raised to the third power. So it's loose. We can just leave that on top. And that 7 to the third gets moved to the bottom. Okay, look at this one. Now remember, the negative is not really being raised to the 0 power. Only the 5 is. So what I have is 1 over negative 1. 5 to the 0 power is 1. The negative stays with it. That just equals negative 1 when I simplify it. Okay, and the last one, again, the negative is not in parentheses. It's a different problem when I have negative 10 in parentheses with a negative 1. Okay, but this one's not in parentheses, so only this moves to the bottom. The negative stays on top. So we'll have negative 1 on top. We'll have 10 to the first power on the bottom, and we're just going to leave it 10 because really you don't really need to write 10 to the first power. And it's simplified, say it's just negative 1/10 is all it is. In the second example, what we're going to look at is simplifying expressions. We have, not only do we have numbers, but we have variables. And so this is an expression, and we're going to simplify the expression. Remember, simplifying means to get rid of the negatives, negative exponents, and the 0 exponents if we have any. Okay, and as you can see, we do not have any 0 exponents, but we do have negative exponents. Okay, in each, let's look at this first expression. We have a coefficient of 5, and we have a variable part a3, b negative 2. Well, the 5 has a positive exponent of 1, which you don't see, and you shouldn't see, but it's fine. The 5 is fine. It has a positive exponent. The a has a positive exponent, but the b does not. So what we're going to have to do is move the b to the bottom. So 5a3 stays on top, and then b2 moves to the bottom. When I move this to the bottom, the negative comes off. So this is in simplified form, 5a3 over b2, and we're good. No problems with that. Okay, look over here. I have a negative exponent here. The negative simply means to move it, to simplify it. So I want to move this to the top. And when I move it to the top, I'm just multiplying it by 1, so I really don't need that 1. So when I move it, it becomes x to the 5th. X to the 5th, okay? It's technically over 1, but we don't write that because we want it simplified. Okay, look at this one. We have the 3 with a negative exponent and the x with a negative exponent and the y with a positive exponent. So the positive exponent stays put on top. Okay, it's fine. We simply move the negative exponents to the bottom. So the 3 negative 2 goes to the bottom, and it becomes 3 positive 2, and then the x negative 2 goes to the bottom and becomes x2. We could simplify this further, and we could say that's y3 over 9x squared if we wanted to do that. Okay, if this exponent were too high, we would just leave it in exponent in power form. We wouldn't, unless we had a calculator, we would probably just leave it like this. But we knew what 3 squared was. Okay, looking at this one, the last one in this set. We have a negative here and a negative here that need to be dealt with. This 4 is fine. So the Z4 is going to stay. Okay, and I will leave it here. That's kind of a big mark, but that's okay. It's a Z4. Now the x negative 5 moves to the bottom, and when you move it to the bottom, it becomes x positive 5. The only thing that changes is the exponent. This y negative 3 needs to move to the top to become positive, so on top it's y3. So the simplified form here is y3 over x5 z4, and that covers this set of examples. In example 3, evaluating an exponential expression. Evaluating means to get an answer. So that means we're going to need to substitute and get an answer for this. This is an expression. We need a numerical answer, a solution. Okay, so what we're going to do here is we're going to write the way I like to do it, and the way I show everybody how to do it is to replace the variables with parentheses, and it's easier done without a tablet, but mine's going to be really ugly. Parentheses here, -2. Okay, so I would probably move this -2 to the bottom first, but anyway, let's do it this way. So we're going to put the 2 here, and then we're going to put the -3 there. Okay, now we're going to simplify this. So the 5, this has a positive exponent, this has a positive exponent, this has a negative exponent. So we're going to take this and move it to the bottom. So I get 5 times 2 to the 3rd over -3 squared. Okay, now let's do some simplifying. 2 to the, you got to do exponents first. So 2 to the 3rd power is equal to 8. 2 times 2 is 4, times 2 is 8. 8 times 5 is 40. Okay, so 40 on top. On the bottom, the negative is squared along with the 3 because it's in parentheses. You square that, you get 9. Okay, now improper fraction, we can probably just leave it like that if we wanted to, or we want to make it a mixed number, we certainly could. That's going to be 4 and 4/9. And that is the simplified form of that one. Okay, let's look at a few of the others. That's probably one of the worst ones. Okay, -S2. We're going to put the negative, we're going to put the parentheses where the variable is, and we're going to put a 2 there. Okay, S is 2. We'll put the 2 there. Notice the negative is not in the parentheses. I'm not squaring the negative. I'm going to square the number and then put the negative on the answer. So 2 times 2 is 4. You get -4. Okay, let's do the -t³. Okay, negative, put parentheses where the variable is, put a 3 there, t is -3. Okay, we got a bunch of negatives here, but we're not looking at this one yet. We're just looking at the one in the parentheses. If I cube this, I'm going to get a negative answer. Okay, so -3 cubed is -3 times -3 times -3. That's 3 negatives, so that gives me a negative answer, and that gives me -27. -27 paired with that negative gives me a +27 for an answer. So I have 3 negatives here, 1 negative here. That's 4 negatives. That's an even number that gives me a positive answer. Okay, let's look at the next one. I've got a 2. Okay, we're going to remove the S, put parentheses, put a -2 there. Remove the T, put parentheses, put a 2 there. Okay, the S is 2. T is -3. Okay, this one moves to the bottom. These two stay on top. So let's rewrite this. I've got 2. I've got -3 squared on top. And on the bottom, I've got 2 squared. I don't need parentheses because there's no negative there. Okay, so the bottom we have 4. That's easy. The top, if we square -3, we get 9. 9 times 2 is 18, right? 18. Okay, that's not going to be a whole number when we divide it, but we can certainly reduce this a little bit. We should get 4.5. If we divide by 2, we get 4 halves. I'm sorry, 9 halves. And that should be 4.5, or 4 1/2 if we want to do it that way. And that's probably a better way. Okay, let's do one more and call this section done. Okay, I've got a 4. Now I've got a 4 on top. I'm going to go ahead and put the others on the bottom because they're negative exponents. So I'm going to have S to the +1. It's going to be 2 to the 1st power. And I'm going to have T to the +2 on the bottom. So I've got -3, and it's going to be squared. Okay. Now remember, this negative does not go with this negative. This negative simply tells you where to put it in the problem. This is a negative on the 3. Okay, let's go ahead and do the work. On the top, we get 4. On the bottom, I get a 2 here. 2 to the 1st power is 2. I get 9. I get 18. 4 over 18. Which, if you reduce that, you get 2 over 9. And there you have it, evaluating exponential expressions. Now remember, simplify simply means to get rid of 0 and negative exponents here. Some of these One of these is going to be really, really easy. Some of these might get a little tricky. So I decided to do a section of harder problems just to kind of help with the easier ones. If we can get through these hard ones, the other ones will become much easier for us, as long as we understand what we're doing. Okay, let's look at the first one. Again, the first one is the best one. Okay, it doesn't matter what any of this mess is in here. There's parentheses around it, and there's a 0 on the outside of the parentheses. So that means this, whatever number this equals, is raised to the 0 power, and when you do that, you get 1. Okay, that's the best one of the group. 1 simply equals 1. Okay, again, it's because it's all in parentheses. In this, it's kind of hard to see. These parentheses should be bigger, but they're not. But the 0's on the outside of the parentheses, and everything inside there is raised to the 0 power, and that equals 1. Okay, the next one, a little bit better. Okay, we're going to simplify this, and then we're going to multiply. So 3 squared is 9. I've got inside the parentheses 2 plus 6. Only the 6 is raised to the 0 power, so that equals 1 times x cubed. That's just x cubed. Okay, so I simplify that a little bit more. Now it's distributive property. So I get 18 plus 9x cubed. Okay, it's that times that times that. These are not like terms. You can't add them. So that is in simplified form. I would probably prefer to have the x cubed first, but that's going to be fine for us now. Okay, that one wasn't too bad. Just a couple of steps. So we got the third one. We got fractions. Yuck. Okay, so let's see how this is going to work out. I've got 3 over x squared. Okay, now first I'm going to get rid of these negative exponents. The 2 is, I've got a plus sign here. The 2 is going to stay on top. Okay, this x squared is moving to the bottom because it's got a negative exponent, so I'm going to put x squared down here. This 2 to the negative 2 moves to the top, becomes 2 squared. Now, these are multiplied together, okay? So now what we have is 3 over x squared. Now we're going to multiply this, so do the exponent first. 2 to the second is 4. 4 times 2 is 8. So we have 8 over x squared. Notice the denominators are exactly the same. So when they're exactly the same, you can add the fractions, and you get 11 over x squared. And we're going to leave it just like that. Okay? Again, a little tricky, but not too bad if you just take each part on its own. Okay? Let's look at this one. Okay, I'll put it up here. So we're going to leave the 2 in the first one. Let's make these fractions here. We're going to leave the b down here, which is what we want. B stays on the bottom. Okay. The x negative 2 is going to move down here and make it x2. And it doesn't matter where it's at. I'll just put it right there. The y2 is going to stay on the top. Okay. So we get divided by, and let's look at the other fraction. Well, everything looks good over here. There's no, I probably could have skipped this step. Okay. So that everything looks good here. Okay, but when you divide fractions, you keep it, you change it, and you flip it. So 2b over here, r3, y3 on the bottom. Then you simply multiply. And we can do a little cross-reducing here. Although this is can get a little bit sticky, we can do some cross-reducing. Okay, this b and this b cross-reduce. Okay, they go away. B over b is equal to 1. That's like b to the 0 power. Okay, I do have something else that can cross-reduce. I have 2 y's here, 3 y's here. So if I get rid of those 2 y's, I've got 1 y left. Okay, they cross-reduce. Now I think we can multiply. On the top, I get 4. On the bottom, I get x2. I get an r3. I'm just going to put it in alphabetical order. And then I've got an extra y hanging out there at the end. Okay, that was a little bit advanced. That was a little bit difficult, but that is how you work that. It's kind of an ugly answer, but that's it nonetheless. Okay, let's look at the last problem in this group. I think we can go back. Okay, so we've got 3 parts here. We got first, we got a minus sign, we got a plus sign. So let's do the first one. I want to simplify that. The negative means put it on the bottom, so I get 1 over 3. Got a minus sign. Now the negative here means put it on the top. So I'm going to have 2 squared on top. I'm just going to put it over 1 because once you move that up, it's just a 1 on the bottom. You don't really have to write that, but since we're doing fractions, I thought I'd go ahead and do that. Now here, the 2 to the 3rd power is good. There's no negative exponent. We're just going to multiply 4 times 1 over 2 to the 3rd power. And we're going to evaluate this. So I should get 4 over 2 to the 3rd power, which should be 8. 2 times 2 is 4, times 2 is 8. And that's equal to 1/2. Okay, so let's simplify this a little further. 1/3 minus 4 over 1 plus 1 over 2. Now, to add all of these fractions together, you have to have a common denominator, and that common denominator is 6. Okay, and 6 here, and 6 here. Okay, now really, since this is a whole number, I really wouldn't do this. I would just actually forget this. Let's do it this way. We don't want to mess with this. Okay, that may mess you up. Okay, 3 goes into 6 2 times. 2 times 1 is 2. 1 goes, that's going to be 24. And that's why I didn't really want to do this. We could have just made this the whole number, but we'll go ahead and do it this way. 2 times 3 is 6, so 3 times 1 is 3. Okay? Okay, so I have a positive 2 and a positive 3. That's a positive 5. And I have a negative 24. That's going to give me a negative 19 over 6. Okay, again, positive 2, positive 3, positive 5, negative 24. That gives me negative 19 over 6. Now that's going to be negative 3 and 1/6. Negative 3 and 1/6. And that is our final answer. Yeah, that was a bit sticky, but we made it through. Okay. This last set of problems, we're being asked to rewrite the fractions with all of the variables in the numerator. It's not asking us to simplify. Simplify simply means get rid of the negative exponents. Rewriting them with all of the variables in the numerator means we're moving this variable up and this variable up, whether they need to or not. Okay. So to do that, I'm going to keep the 3, not writing, let's see. Keep the 3x4 in the numerator. Okay, I'm going to leave the 5 in the bottom. It's not a variable, it's a constant. I'm going to move the y3 up. It becomes y3 because it's negative 3 down here. I'm going to move the z4 up. Now again, if I'm simplifying, I don't do that. But I'm not being asked to simplify, I'm being asked to move it up. So when I do that, it becomes z negative 4. Okay, and that is the answer they are wanting. All of the variables are now on the top. The negative 4 tells somebody that z is not really supposed to be there. It's supposed to be on the bottom. Okay, but that's the way we're writing it now. Okay, let's back this up and let's see if we can go to the next one. Okay, we're not simplifying. We're not going to move this x negative 2. We're going to leave it. It's in the numerator where they want it. Okay, the 7 needs to stay in the denominator. It's a constant. I'm going to move the y3 and the z7 up. When I move the y3 up, it's got to change, so it changes signs. Not the y, but the exponent. The z7 moves up, it changes signs. And that's it. It's as simple as that. And instead of backing up, I'll just leave that. Okay, let's go here. Again, I'm keeping everything in the numerator, so I'm not going to move the a negative 2 down. I'm going to leave the 9 on the bottom. It's a constant. I'm going to move this b8 and c negative 3 to the top. When the b8 moves to the top, it becomes b negative 8. When the c negative 3 moves to the top, it's c3. Again, when you move something within the fraction, the exponent changes signs. If I were to move this 9 up, it would be 9 to the negative 1. But because the 9 is, I'm keeping the 9 on the bottom, I'm not going to do that. Okay, here the 13x9 stays on top. The 7 stays on the bottom. I'm moving the y and the z up. They both have an exponent of 1. So when I move the y up, the exponent becomes negative 1. And when I move the z up, the exponent becomes negative 1. And I have to write that because it has a negative. When it has a positive 1, you don't really have to write the exponents. But when it has a negative on it, you have to write the exponents. That tells somebody those do not belong in the numerator. But that is how you do those. You're just simply moving these up and changing the sign of the exponent when you do.